My name is Bryce Wuori. I own Wuori Consulting and designer, owner of PaveWise application, which is a quality control program that we developed in-house using technology tools to pretty much help contractors implement a quality control plan. We take technology tools, including like the GPR here, the PaveScan, thermal imaging from paver mounted to even just cameras, even intelligent compaction, and we take these tools and data sets and create optimum conditions for paving and really set up these technology-based quality control programs and methods for them to really hit specifications and hit incentives and do well on these projects. So
cool. That sounds very interesting.
Yeah.
How long have you been in the industry for?
I've been in the industry since 2012 in the asphalt paving industry. I've been only doing this consulting for 4 years now.
Okay.
As myself, or as Wuori Consulting and PaveWise, 4 years. So.
Okay. And it's going well?
Yes, going really well. It kind of just started out as a side thing, and we were implementing technology tools like intelligent compaction and thermal imaging into the paving, working for a contractor, Midwest contractor here. And I seen what these technology tools were doing for quality, especially when you manage the data correctly and implemented them correctly. And there was a big link that I seen missing out there in the industry. Mm-hmm. A lot of these technologies were getting pushed onto contractors and they just didn't know how to use them correctly. And there was just a big opportunity, and I jumped into it, and it just kind of caught like fire, right time and right industry. So
how did you originally find out about PaveScan?
My good friend Richard Giesel from the Alaska DOT. Yep.
Okay. That's what Rob thought.
Yeah, he knew what I was doing with intelligent compaction and the PaveScan application, and I really was missing a part of the whole thing where I needed to collect data more efficiently, get more data sets to plug in. And he kept bringing it up to me, and I was like, well, let me look into it. Let me see. And he'd send me over videos and data sets, and I'd look at his longitudinal joint uniformity formulas. And I'm like, well, I should really, okay, I'll look into it. And then I actually got on a project and was able to see it run in person. I was like, yeah, I think I ordered one like 2 months later. And I was like, this is what I was missing. So yeah.
That's awesome that he spread the word to you and you're spreading the word to everyone else that you're contacting. So Rob told me that you went on a ton of projects in 2020. Yep. And what were the benefits that you saw using PaveScan?
The biggest benefit was we use it here in more of a proactive manner, right during paving operations, behind that intermediate roller, and then behind the finished roller. We're pretty much real-time data, using it to judge and check on how our other quality control tools are doing, our segregation, through the thermal imaging, the intelligent compaction. And what this tool allows us to do is collect that data, find these areas, and eliminate them or manage them way quicker than the traditional nuke gauge, or trying to shoot the amount and getting the data with a nuke gauge or other ways that we were doing it. Literally, I'd have 3 guys running nuke gauges. You can run around with one person in the PaveScan, or myself. That's what I do, and I'm collecting way more data and getting a lot better results with it than I ever dreamed of with a traditional nuke gauge or non-nuke gauge.
That's awesome.
Yeah, let me do a follow-up question with you.
Yeah.
When you were going in between the rollers, one of the things that Richard does, and I know a couple other DOTs, I was wondering how you collected data, whether it was along the road, back and forth, or across the road.
Across.
Huh?
Always across, transverse. Yeah.
Okay.
What I'm looking for when I'm doing that in between the intermediate and the finish is that mat isn't fully compacted. What I'm looking for is uniformity there. For the majority of your rolling density comes from the knockdown and the intermediate. So if we can keep those 2 rollers or 3 rollers the most consistent, that's where the majority of your uniformity comes from. The finish roller isn't doing a whole lot for uniformity. It's taking out lines. The 90 to 95% of the density is achieved already with those rollers in front of it. So that's how we're doing it, cutting it transversely, looking just from uniformity from shoulder to center line.
I guess the best question to ask you is how long would it take you, for example, in between the rollers and then maybe perhaps after the finish roller? You know, how much time would you say it probably took in those instances?
Generally, we're running this back behind the finish roller on if the project had a longitudinal joint spec, I would run it back on the longitudinal joint and then hit a certain station, come back and do the swerve method up to pretty much that same starting station. And then I would stop there and I would jump up in between the two rollers every, I'd say probably every 5 to 10 stations, just to look for uniformity in between the intermediate and the knockdown, just to look for uniformity. And then I'd bump back and pretty much it was running. This machine was running nonstop during production, just like a nuke gauge.
Okay.
Yeah.
Was it your responsibility perhaps to, and I'm guessing to the finish roller or even to the project manager there, to let them know that, you know, it was definitely lower density or non-uniform, but lower density in certain areas, and the finish roller would roll over that spot, or even corrections were being made in real time?
Yep. What we would do is if we found an area of low uniformity or where we weren't in our optimum data sets of what we were expecting for quality, what we do is most of these projects I was actually running as the quality control manager or the technology manager. Okay. So I would make the decision to let's keep moving forward. We'll put an extra roll pass on it with this roller. And if we track this trend and it's continuing to do the same thing in these locations, say it's the shoulder, center line, middle of the mat, so many feet apart, we would then change something in the actual procedures, operations, roll passes, speed of the paver, look at the thermal data. Once we found those areas with the PaveScan, we would look at our other technology tools to see if they matched on finding these same issues. And then we try to identify it.
Did you integrate some of those technologies? Or you just had them side by side type of thing?
I integrate all of them. That's what my PaveWise project and application does. I integrate thermal, intelligent compaction, and now nuclear testing and the PaveScan. And that's what this program does. Is it develops trademarks and trends and optimum conditions based off of those variables, dynamic variables and constant variables. So dynamics being wind, ambient moisture, also if you're moving from different sections in the road. Constants are mixed designs, typical section designs, your roll passes, IC data, GPR, all those things. So we track up to 27 different variables throughout that program. One is your guys' technology, definitely. So
awesome. That's good to hear.
Yeah.
That sounds like a lot of work to manage all of the different technologies in one. Do you find it overwhelming to do all of them?
No, not too bad. That's pretty much what we developed the application for, was to minimize all the data sets and looking at all these different tools and integrating it into one simple program that really can track these, and one user can sit behind it, and we implement the IC data sets and all this, and we can really track and find these areas of and it's pretty neat. We're still learning a lot about it, but we're finding these data sets that match up and the causes of them and how these technology tools identify them, and they're almost always common trends. And so that part of it's really neat. And the headache without the program is, it's almost impossible to use these technologies and understand the data, use them efficiently, and really get good results with them. It's almost impossible, or it's a headache to track all this and use these correctly. And that's where I really started working with contractors, is because they were getting frustrated. I have all these technologies, I have all this data, but I don't know how to use it. And it's just more of a nuisance than I'm getting a benefit out of it.
So do you mainly work with contractors then? Do you work with
I
any
work-
DOTs?
Yeah, I just have a weird, I work with agencies from Napa to the Virginia Asphalt Association to about 9 different contractors across the United States right now. DOTs from Alaska to down in Arizona to Virginia to the 5 states around me here. So I work with anybody who wants to learn more about it and want to implement technologies into their programs just to help push the industry forward, I guess.
That's awesome.
Yeah.
When you pull up to the job site, do people know that you have all these technologies kind of that you're ready, that you're coming to train them and show them the possibility of what this can happen?
You know, it changes depending on what contractor I'm working for. A lot of contractors I work for are now set up with a lot of these technologies. They're just running them part of their quality control process now. I mean, when they're out paving, they're running IC, they're running thermal scanners and cameras. I mean, it's just what they do, and that's what we found such good results with it. It's part of the program. But the newer contractors I work with, yeah, it's always kind of a little bit of a scary when I show up, because, you know, we start running the PaveScan and it's their first time ever running IC and thermal, and it's just it's kind of a big awakening, and it's a big lot of things to take in. But you know, generally the majority of contractors I work with want to make changes. They want to push technology, so they know I'm bringing these things, and they kind of prepare for it. But the biggest thing is I have had both sides out in the field where I start running the PaveScan for, and this is when I'm working for more of an agency. I come out with the PaveScan and I start running it on a joint, and the contractor, you know, gets a little nervous, or what's that doing? You know, what you can see, you know, and they follow me around, and is that showing real time? What's that number mean? You know, and they don't quite understand it, and they're thinking I'm just trying to find an area that to put a core for them to fail, and they, you know, but once they understand it, know that we're running it to benefit them, you know, really benefit them, it changes pretty quick.
Awesome. Thank you.
Yep.
Okay, so Rob is always talking about how PaveScan is minimizing coring and being safe on the job site. What is your take on that?
Oh, hands down. I am one of the, probably in the industry, if you talk about destructive coring and random coring, I am totally, the whole process bothers me. When we're judging what a contractor, how well a contractor is doing off of less than 1% of the mat lot, you know, and just the minimal amount of data you get, and as from a contractor's perspective, being judged how well you're doing based off that little bit of data, and then making judgment calls off of it, and procedure changes is just, I've seen it go the wrong way so many times. So I really hope the industry moves towards more non-destructive coring using technologies like this, because we get way more data. It's a way better representation of that road. It's way safer. Destructive coring is done usually in low light conditions after the paving or early in the morning. And I'm seeing more and more agencies going towards more cores per lot, or now with the joint density on that center line, 2 cores on that center line. That's the most dangerous spot to take cores, out on the center line of a road and traffic. And there's more and more of those taking place procedurally, and it's a scary deal. So yeah, this tool definitely, I believe, would help in minimizing that footprint of destructive coring.
Thank you.
Yep.
Rob, did you have anything to add about that?
Yeah, just a question. I know you said you've been working closely with Richard Giesel, and I know he's been an advocate of the joint density stuff, or, you know, his pay factor up in Alaska, actually, he pays the contractor pretty much of joint density. And
Yeah.
certainly he has, you know, created procedures, I guess, to improve joint density. Are you doing the same thing? Are you spreading that word, or how much involved are you in that?
Yes, I helped the North Dakota DOT set up their joint density specification. I know they have a couple of PaveScans as well in their operations. I work very closely with Amy. I talk to Amy probably every other week. You know, I just sent her over a whole bunch of data sets from a project where I was able to shoot the core locations with my GPR, and I'm waiting for the contractor to release the rights on that stuff because the project hasn't officially closed out. But that specific project, I was able to shoot over 200 core locations with the PaveScan this last year and compare the actual core results to the dielectric taken in these core locations before the destructive coring was taken. So I have the dielectrics in the time mode in these locations and the actual destructive core results, and it's just a comparison of the two and how they just kind of lined up in the results, and it's pretty neat data. But yeah, I'm a big, just like Richard, I see the benefits of it, especially in the uniformity factor of identifying the consistency of these mats, and I truly believe uniformity is something that's really underlooked right now in our industry, and it's probably one of the more important things in when you look at the life of asphalt, this life cycle, and just how it's going to perform. Uniformity actually goes over into even ride, and so I hope that more agencies get into a pay factor like that, using the PaveScan to set up a procedure payment, and use it to really pay these contractors or get a better representation of these roads and pay them based off of a better representation of what they did in the field, rather than 5 random cores, 1% of that lot. So definitely.
I mean, I agree with you, the coring thing, because again, not only is it dangerous, I talked to I won't give names, but to a contractor up in Wisconsin, and his daughter is in charge of collecting cores. That's what she does, and she does this, as you say. I've been there too. You've been there, I'm sure. In the night, 2 o'clock in the morning, hoping someone's not texting and going 70 miles an hour down the road, you know, and that's what keeps him up at night. Anything, you know, it's like the budget doesn't keep him up at night. You know, the paving for the next day doesn't keep him up at night. Any issues with rollers doesn't keep him up at night. What keeps him up at night is his daughter's out there at 2 o'clock in the morning collecting cores. And you know, and then the second thing is that it simply just puts holes, you know, on a new mat.
Yeah.
And so I never understood. I mean, I know that's the only way they could do it now, but I think this is something that is certainly going to change the industry. That's how I see it anyway.
Well, and I know you've seen it too, but I mean, how are these core locations? I mean, they take a flat pan steel rod, and that's how you get density after you fill the core back in. And you look at it, I mean, it's going to be an area that fails prematurely, for sure. I mean, there's no density. The areas, well, on the joints, those are already areas mechanically, just due to the constructability of a centerline joint, is lower density anyways. So you're taking 2-3 cores out of these areas that are already prematurely could fail before the mat, and then putting mix back in there and giving it a couple pounds with a flat headed bar. I mean, it's just
I've seen them, yeah, shovel the asphalt in and then kind of either pound it with their boots.
Yeah.
So okay, it's dense enough. You know, I've watched that.
And here's the other problem with destructive coring. I've watched thousands of cores be taken out, and I mean, the process of actually using, you know, the saw and cutting them, and the angle of that saw is not always straight. You use your foot to keep it. I mean, the results aren't always perfect with those either. I mean, I've seen I've been part of a few where it's like, oh, we got to re-core there. That core that's not a good representation of that area. And then, you know, in a simple box, you could see a core difference between a 92 and a 95 within inches of each other. And it's just, it's hard. It's one of those procedures. I mean, it's done, it's mechanical, you use a saw. It's, you know, if you're not cutting it right, if you're not doing it right, and even, you know, putting it in the oven and weighing it, the whole procedures, there's a lot that goes into it to get consistent numbers and trustworthy numbers.
Yeah, I've heard the same type of stories where I was in up in Canada, and I went over a certain area with PaveScan, and you know the dielectric drop, so it was a low density area. And we had a nuke guy out there, and he came, and I was with my colleague Yan, and we called the nuke guy over. Says, "Can you take a nuclear gauge reading on this spot right here? Just, you know, we want to just compare real quick." And he pulled up like 94% or whatever it was. And said, "Wow, that's good density." But you know, my sensor, my PaveScan shows low density. So I decided, well, let's just do a retest. So what I did, I had 2 extra sensors in my truck. So I pulled another one out and went over the same spot, and again, it dipped. So we asked the guy to come back over. "Can you take one more reading?" And he took a reading, the same spot again. And it was like, you know, 91%. Same nuke gauge, same spot, 2 different readings. It was okay.
Mm-hmm.
That just told me everything I needed to know, like the consistency part, right? So
Yeah.
I've heard stories like that many of times.
And I've used nuke gauges for years, and they've helped consistently with trying to, you know, for quality, but they have their place. And I've the same thing. I struggle, especially on these gap graded SMAs, open gap graded bony mixes, where a nuke gauge, if you got to put a filler sand in or something, and then you turn it completely 180 or even just a little bit, you're getting a 2% difference in that same area with these nuke gauges. And that's where I was getting so frustrated, was it's just the inconsistency of them based off of the science behind them. It was frustrating because you didn't know if you ever could trust those numbers accurately enough to really know if you needed, if the results were good, if you needed to make changes, or, you know, what was going on.
How do you see PaveScan changing the asphalt industry?
I see it changing a couple different ways, just depending on what part of the industry you're in. For contractors, I can see it being a tool to kind of get a competitive edge as far as using it correctly to really knock quality incentives out of the park. If you got a project with ride, you got joint, you got a mat density, you can really hit those pay factors high and use it to really get those numbers and hit that quality perspective. So it's going to change that part of the industry. Once these contractors grab a hold of it and see what it can do on the quality side of things, it'll just become a norm for them to use, just like a nuke gauge, I believe, when used correctly. I already see it happening, you know, with the projects I'm on. And then as far as the industry as a complete asphalt industry, changing the ways, you know, in testing, safer ways of testing from non-destructive, getting better representations of the road, using it as a link between these other technology tools, and really moving forward with real-time data and proactive quality control, using these real-time data technologies to make adjustments, not doing this old reactive method that we do and making adjustments a day after with cores and nuclear results. So I see it really innovating, pushing, you know, the industry forward with building better roads and just better procedures for more consistent, uniform, dense roads. I do, definitely.
Awesome. And I think that's ultimately the goal, right? You want better roads that are
And last longer.
Everyone money. Yep.
Yeah. Yeah, it's amazing because I sit and think about like what a little bit of quality mindset and initiative it does, even just contractors, agencies. If we, you know, and you've probably seen the results at like NCAT, like the 1% increase in density is 10% increase in expected life, you know, and And that's what's amazing is like a lot of these projects that I work on, it's almost an average of 1 to 1.5% average higher density. And there's always a uniformity factor and consistency that is very satisfying. And we do that using technologies, and the PaveScan is one of them for sure. So.
Okay.
Awesome. Thank you.